Alright guys, so today I want to go over truth tables and truth values in propositional calculus, or also known as, it's basically a topic that is discussed in discrete mathematics, and you're also going to be learning a lot about these things, and you're going to be seeing a lot of these things in your higher level courses. So let's go over them. So let's just see. We have propositions P, and we have propositions Q. Right, and these can be either true or false, right? True, false, because that's what propositions are. They're true or false, right? So let's see if we can have our standard 1 1 true false false true or false false, right? And let's actually separate this. And if I write something like P and Q, and is basically the conjunction, right? And if we learned in this, and if we, when what we learned in discrete math is that a conjunction is basically true when both propositions P and Q are true, right? So in this case, our first row would be true, right? Our first respective row, right? It doesn't matter what order what order these rows are in. Like 1 1 can be down here. It doesn't matter. That's why I say respective row. So our first respective row will be true, and the rest will be false. And it makes sense. Like if you think about it in Java, right, and not even just Java, just in general, right? And it'll make a lot of sense too when you read it out as an English sentence. When both statements are true, and, right, when P and Q, when it comes to and, both of them, both propositions must be true. Okay, so if one of them is false, right, if one of these things are false, then everything is false, right? And if we read it in like an English sentence, let's actually give out two propositions real quick. Let's say let the proposition P denote the statement I love longboarding. Okay, I really do. Okay, and let's let Q denote the proposition I love the rain, right? And if you were to read this in a regular or normal English sentence, right? If you were to say I love longboarding, right? I'm sorry, this isn't neat. And you say and I love rain. You're basically saying you love both of these things, right? You're saying I love longboarding and I love rain. You're basically saying, oh yeah, I love both of these things, right? But if one of these things is false, right? If you don't love longboarding, but you love the rain, if I don't love longboarding, right? If I love longboarding was false and I love rain, one of these things are false, right? But you're basically saying two things to begin with, right? You're basically saying two things to begin with. But if one of these things are false, the entire sentence is false. If I love longboarding is false and I love rain, right? You're basically saying a false and a true, right? And anything false and true is always going to be false, right? Now let's look at something, let's look at a disjunction. So a disjunction is P or Q denoted with this symbol. It looks like a V, right? Or it kind of is a V, right? And it's basically true when at least one of the propositions are true. So in this case we have this is true, this is true, this is true, and this is false. And the same way we look at it, the same way we just saw in the previous example, you could look at it this way too. I love longboarding or I love the rain, right? But what if I love longboarding was false, right? But, or, right, it's either or. It doesn't matter which one is true. One of them is true. It's either I love longboarding or I love the rain or I love both, right? And as long as one of those things are true, the entire sentence is true, right? I love longboarding or I love the rain. If they were both false, the entire statement is indeed going to be false. Okay? So hopefully that makes sense. Let's look at another one. Let's look at the implication. P implies Q, right? I love longboarding. If I love longboarding, then I love the rain, right? You're basically saying if you love longboarding, if you love one thing, then you love the other, right? If P, then Q. If I love longboarding, then I love the rain, right? You're basically implying that the person that loves longboarding also loves the rain. But what if one of these things were false, right? Well, when it comes to implication, when it's only false when P is true and Q is false, right? So let's look at when P is true, right, and Q is false. So in this case, this is false, and everything else is going to be true. Okay, so basically, if you think about it like this, Think about it like hypothesis implying conclusion, right? If you have a true hypothesis that concludes a true conclusion, right? That's gonna it's true, right? Your experiment was true. If you have a true hypothesis, however your conclusion was false, right? You basically conducted a false experiment, right? If you had a false hypothesis at first, but it turns out your results were true, you ended up having a true experiment, right? And if you had a false hypothesis and a false conclusion, then your experiment it was true. Like you conducted something was false, and it turned out it was actually false. Like it turned out it wasn't true, and it just makes sense, right? Like if I love longboarding, then I love the rain. If I don't love longboarding, then I love the rain, right? If I don't love longboarding, then I love the rain. Like that doesn't make sense, right? Because you're implying one thing is the other. When one thing is false and the other thing is true, that is a true statement. When one thing is true but the conclusion is false, right? That thing is false. Okay, so hopefully this clears up propositional logic for you guys. There's many more, but just this is just like a basic understanding of it. All right, and I'll see you guys next time. Peace.